Hello and welcome. Today I'm going to share with you a case study about predicted electricity consumption. And normally, a company pays its bills based on predicted consumption, but sometimes they may be asked to pay when they use more energy, and sometimes they may be receiving money back when they use less energy. And they don't want this to happen. So they may want a prediction. And so in order to work in a data which looks like this has a data recorded at a 5 minutes interval. As you can see, it has a date, time, and consumption measured in kilowatt per hour. So what we can do is we can aggregate the 5 minutes data into 10 minutes, 15 minutes, daily, hourly, and weekly also. And we can predict the daily consumption using time series analysis. We will also do exploratory data analysis. So the big question is, why does electricity consumption vary over time? Is that because of the time of the week, or month effect, or seasonal pattern like winter, summer, or long-term trends in usage, or something else? So you may be challenged to forecast electricity consumption by considering a data taken from Kaggle. Kaggle is a platform where data scientists do statistical analysis, for example, using Python. And this data is consumption and production of data from Romania. I clean the data, and the data is in Excel file and also SPSS file. So we can use time series analysis. What is time series analysis? Time series analysis models data that is collected over time. It can be hourly, daily, weekly, and it will help us to identify patterns, if there is any fluctuation, if there is seasonal effect, if there is any trend. So the goal is to forecast future values based on past behavior. There are main components. One main component is trend, and we usually use common method moving average. This is one example of increasing trend. There is seasonality component. We used exponential smoothing. This is an example for seasonal pattern because it shows similar pattern every year. And another component is residual, and residuals are very important components in modeling time series data, for example, in using ARIMA models. This is an example of a plot for residuals when we model our data using ARIMA 111. Just to give you a highlight on the time series models, I'm going to focus on four core time series models. The first one is autoregressive model. This models the current value as a linear combination of the past values. Moving average model models the current value as a linear combination of the past forecasted errors. And ARIMA is a combination of autoregressive and moving average, and it is perfect for stationary time series data. ARIMA has one additional component, which is the differencing, and this is perfect for non-stationary time series data. So you can use different environments to analyze. For this, I'm going to show you how you can do time series analysis using R, specifically RStudio platform. So the first thing that I need to do is I need to read my data from Excel or CSV. So I read my data. This data is the consumption and production of data from Romania. And then I can see how the data looks like. If you look at it, I have also production and other data, but I am interested only to consider the consumption data. So that I do it here using this code, and then I can see the top 5 data, how it looks like. So here in this code, I just took only the consumption data, head or the top 5 observation for the consumption data, and then the length of the data. And I need to also define the data as a time series by using TS code. This code I use That's how I do, by using TS and also frequency and also the start date or year. And I had 6 years data, but I'm interested only to show you by considering the 2 years data. Now I have a time series of the whole year, but I want to take 2 years of data using this code. This is the length. I can plot the whole data, as you can see, and I can also plot the 2 years data. And now the next important thing is I need to model it. Then the next activity is to decide on the type of model that I'm going to use. I can also use automatic ARIMA models because R has that option, but I can also suggest by myself. To model it, I want to divide my data into trained data and test data. So 1 year and a half data for trained data and the half year for test. That's how I did it. This code did that. And then I can check the length here. So the next is to model. In order to model, I need a suggestion. So for example, in this case, I want to show you how we can use ARIMA models. In ARIMA models, I have the auto regressive of P, order P, or lag, a moving average of Q. If I'm going to use ARIMA, P, D, Q. So I need some way to know what the value for P, Q, and the D. D is a differencing, so I can know from that, but P and Q. For that, there are important plots. These plots, we call them autocorrelation function and partial autocorrelation function. This one we can get from the partial autocorrelation function. The value for this one we can find from the autocorrelation function. So that's what I'm going to do now in R. This code is the partial autocorrelation for the whole data, the partial autocorrelation function, and this is with lag, maximum lag of 50. And then if you see, I have 2 spikes. The first lag and the second lag are spikes. So I can use P as 1 and also 2 suggestions. I can also do for the moving average lag. And for that, this is without differencing, so it will not help me. So I have to difference it once. After differencing once, there are spikes until the third lag, but then after the third lag is decaying. So Q can be 3. So I have the following. I have for this one, I have either 1 or 2. For this one is 1 differencing, and for this is 3. So this is 1, 3. So I am going to show you using one of these. Let me consider 2, 1, 3. ARIMA 2, 1, 3. This is ARIMA 2, 1, 3. This is the coefficients. And then I can forecast. This is a forecast. I can plot the whole data and then the forecasting. Because what I did was I used 1 year and a half data for forecasting the next 6 months. And then you can see how it looks like. The red line is a forecasted mean. And then, so the forecasted mean is within the 95% confidence interval. And the prediction is linear, as you can see. But I need to check also adequacy by looking in the residuals. And when we check the structure of the residuals, from the residuals, it tells me that this model couldn't handle my data. So I need to look for another model, yeah? And I can repeat similar steps. And I can also check the normality by looking into the histogram or QQ plot. That's similarly how you are going to do. So what is expected from you? You can work on the data that I gave it to you. And this data originally is consumption of data and power and light company in the US. They had a data of 15 years, but I only took a data of 6 years and divided into 3 groups, each group to have consumption of 2 years. I clean the data so that it will be easier for you to work on it. And the data is uploaded to GitHub. And the link is shared with you. So you are expected to identify trends in seasonality, to apply smoothing or ARIMA forecasting also, and evaluate forecast accuracy and communicate the results and make recommendations. All of the groups have the same activities, and you can use Python, SPSS, or R. See you next time. And for today, thank you very much and bye.